once, do it right, and you're all set. Okay? Once your classification is done, then you can be sure that your metadata will be stored properly in the PLM system. Now, how about your geometrical and your footprint information? And this is where my HTT experience comes into place. Not only we can bring the metadata from your EE tools to your PLM system, we are also going to bring you the footprint information and the geometrical information of every EE component in the PLM system. So we've developed a fully customized automation at MyHTT where we take your footprint information from Xpedition. We take your 3D geometry for every E component from a step file, and through an automation, what we call at Maya the ECAD importer, will bring both information inside NX in Teamcenter. So you will have your 3D geometry, as you can see here. You will have your pin information, your pin labels, your pin curve. You will have your MMC curve, and using the package height, you are going to extrude that MMC curve and have what we call the MMC, or the maximum material condition bounding box. All stored in a UG master in an NX file within Teamcenter. And this is done automatically. So not only we store the metadata, but we also store the geometrical and the footprint information for every single component in your library. If you have 10,000 of components, you will have 10,000 of these. So this is how it looks inside NX. So here I have in purple I have my MMC body, so maximum material condition. You have your step geometry, your 3D geometry coming from the step 5. The automation will automatically align the footprint with the 3D geometry, and this is a common mistake that we see in the electronic industry today. Their footprint are not aligned with geometry, 3D geometry. You have your pin information, so your pin curve, your pin labels. And also we detect automatically the pin number 1, and we make sure that everything is aligned properly on the model. This is pin number 1. We set the right attributes so they can be consumed properly in downstream system in PCB Exchange. And we are going, as we will see in the next couple of seconds, we are going to create the right reference sets and layers. So we're going to put the MMC or the pin information in one layer, in one reference set, the 3D geometry in different layers. And I will explain why in the next couple of slides. You can turn on and off and see the different, and you see that everything is aligned properly and that the librarian has done his job. This is the first step. Metadata, 3D geometry, footprint information. Okay? Sounds good? Perfect. Second step. Now, I'm a librarian. I create a component in my EDM library. How I push all this information automatically. So, not working properly, that's fine. So you have here on the top left, you have your EDM, you have your librarian. He created a part request, create his component in EDM. You have all your metadata in EDM. You have your footprint information in Xpedition cell. The librarian will push what we call a EDX file that will contain all that information. And through the Teamcenter EDA gateway, which is a Teamcenter module that will make the connection between EDM and Teamcenter, that component, or more specifically, that metadata will go through EDM to Teamcenter, and the process will automatically create a new item in Teamcenter and will classify it with the proper classification class. Is it a capacitor? Is it an inductor? Is it a resistor? Remember, each classification class has classification attributes. The system, the EDA gateway, using some sort of mapping, because on the EDM side, you can have, let's say you have a resistors, and the resistance attribute is called resistance A. On the Teamcenter side, when you create your classification, you call it resistance B. you need to make sure that the system understands that this is the same property, right? So we use what we call XML mapping, making sure that, okay, your property in EDM are mapped to your property in Teamcenter in a way that when a component is pushed from EDM to Teamcenter, the component will be not just automatically created, but also automatically classified with the right classification attribute. And at this stage, you will end up with a component in Teamcenter only having the metadata properly classified. And this is where the ECAD importer that you see on the top right will automatically detect that a new component has been created, go and fetch the footprint information from Xpedition cell, the 3D geometry from the step file, and bring all that information into Teamcenter in the item created previously. And you will end up with the metadata, your 3D geometry, and the footprint in one item in Teamcenter. And it's not only one timer. It's not only when you create component. This workflow will happen if the librarian updates something on EDM. That update will automatically be reflected through the EDA gateway to Teamcenter and go update the footprint, or update the step file, or update the metadata if you change any attribute. Now, I'm an MCAD designer. I'm doing my PCB board. Oh, sorry. I would like to add a connector. I'm within NX, manage mode. I have access to my browser, active workspace. I have my EDA library properly created, my single source of truth. I would like to search for a connector. If I properly create my classification class, this is straightforward. I can filter, I can search whatever I want. Here I want a connector, so I'm going to search for a connector. And I want a connector with 16 pins. I've created my classification properly, so I should find a connector with 16 pins automatically. So these are my classification attributes that you see on the left: the footprint, the package name, the pin count, the resistance, the tolerances, and so on. I would like a connector with 16 pin. I have one in my database. I drag and drop. I put it on the board. And I won't just see a yellow box. I will see the 3D geometry of the component. And remember, you got the concept of reference set that I talked about in the previous slide? Perfect. Here I can switch to another reference set and see the footprint information on my board. Or I can see the MMC box and make sure that when I place a board on the component, I have enough clearance with other components. I have no intersection or clearance issues.
Don't people do this in Xpedition?
Yes, but when you put it here, there is no guarantee that it will work on your PC, on the MCAD side. EDM library design integration. So step 1, step 2 is at the component level. Step 3 is at the design level. Now, this is my workflow. This is what I had previously. This was at the component level. What I'm adding here is at the design level. So I will use the EDA design integration. So you have your layout designer in Xpedition layout doing a PCB layout. You have your schematic designer doing the schematics. You create your PCBA sets in Xpedition. You're ready to publish, you're ready to release. Using the Teamcenter gateway for EDA, once you click Save on EDM, all the information will end up in Teamcenter. All your PCBA items, and each item will consume one component of your existing library, like a connector or resistors. You will end up with all the fabrication file, all the schematic file in one single place, which will be your PLM system. So the EDA gateway for Teamcenter, it's an out-of-the-box tool. When we configure it, when we customize it, we need to implement what we call the EDA callbacks. So what happens when the user click on Save in EDM? What are the information that are transferred from EDM to Teamcenter? How do you manage the revision rules from EDM to Teamcenter? All this information, it depends on the business rules of every specific customer. It's not the same rule from customer A to customer B. So that's why it's implemented via what we call the EDA callback. But the end goal is the same. The end goal is once you release your first baseline in EDM, all the information is in single place in Teamcenter and ready for collaboration between ECAD and MCAD. And that collaboration is done using IDX5, whether a baseline collaboration or incremental collaboration. So you have some IDX5 stored locally on your machine or on a shared network, where EE people and MCAD people will import, export every iteration and make sure you have your collaboration process. This is good. Is it perfect? No. Why? What is the missing step? The missing step here is the collaboration process. It's very hard to track IDX5, especially when they are stored locally. When you have many users involved in the collaboration process, it's very easy to get lost. Where is my last IDX version? Is it the right version? How can I revert? It's going to be messy very soon, right? So the next step, which is the last step, it's just cherry on the cake, is what we call the co-design process. Instead of managing the IDX file locally or on a shared network, what we're going to do is use what we call the co-design feature in Teamcenter. It's a business object that has been introduced in Teamcenter, I think, 2 years ago, where in background, it's still managed IDX file, but it's transparent. The collaboration is done in the PLM system. So you have a business object in Teamcenter called the co-design, as you can see here. And all the collaboration between EE and MEs are done through that business object. And at any given point, any given time in the design process, you can see in the PLM system who is doing what and what are the changes done. Which can be very useful not only for EE and for MEs, but also for different stakeholders or different downstream consumers of the PLM system. And I won't go into details here, but at Maya we've developed with Siemens an application that my colleague Yannick Sigmund will provide more information in the next couple of days. It's called PCB Connect, where you can visualize all the collaboration and the PCB board information and see the collaboration and track the collaboration history between E and MEs at every point, every time in the design process. And that PCB Connect application can go and read that business object, that co-design object. So this is the end goal. One system, you have all your PCB sets, schematic, your fabrication, your library, your component are, every component referred to one single EE component properly classified in the system, and each component not only contains the metadata but also contains the 3D information and the. So, before leaving this room, there is 3 points that I would like you to remember. Okay? The first one, what we've seen today is what is the process, the standards, the best practices to have real-time synchronization at the component level, at the library level, between Xpedition EDM and Teamcenter on the metadata side. The second point is how you allow MCAD designer to access cross-domain data by allowing them to access footprint information, 3D geometry information in the mechanical software. So they don't need to install or have EE tools to be able to gather any information about their footprint or their MFC. And the third point is EDA design integration, how you make sure that at the design level, when you publish a first baseline of your PCBA set, how that PCBA set ends in Teamcenter, fully in sync with your EDM, with Xpedition EDM. These are the only 3 things that I would like you to remember. Now, and this is how I always like to conclude my presentation. Why choosing Maya HTT? Why Maya HTT is the right partner to implement your best-in-class ECAD and CAD collaboration process? There is 3 reasons. Only 3. Not 2, not 4, 3. First one, proven expertise. We've done this for many years. We've done it from startups to big 4 tech company on the West Coast. As I said here, what I've presented is or Xpedition, Teamcenter, NX, but the concept is the same, whatever you're using EE tools, MCAT tool, or PLM system. We've done it with any combination. We have experience in ECAD and CAD collaboration. The second one, we understand that the standards, the best standard in the industry is the same, but the needs, the business rules of customer A is different from the needs or business rules of customer B. So when we implement a solution, we take care what our customer wants, and we provide unique solutions that will make that customer happy and competitive on the market. Even if the workflow and the standards are the same, even if the end goal is the same, your needs may be different from other customers. And the final reason is future-ready solution. When we implement solution at Maya, I don't want to implement solutions that work for 1 week or for 1 month. I want a long-term solution. I want a solution that if today you are 100 user, you're happy, but if in 6 months you double up, you're 200 users, this solution will still work. So we become not only your supplier, we become your partner, and we implement long-term and scalable solutions. That's it. This is my contact information. I will be happy to take any question. Also, if you would like to